Okay, so if you haven't done so already, what you need to do is go online and print this worksheet out. And I want you to try these problems on your own. So before you do anything, print it out, try the problems on your own, and then come back and I'll help you out with how to do some of these. So the first two problems, notice we've got a line there and it's broken up into segments. So we're going to use the segment addition postulate, the thing that we used way back in the beginning of class. Our goal is to solve for x. They're not asking you for the lengths of the segments or anything. They just say in the direction solve for x. So to do that, we know that this segment plus this segment plus this segment adds up to equal the whole thing, and the whole thing is equal to 23. So what you have to do is basically add all these up, set it equal to 23, and solve for x. So this is x minus 6 plus 9 plus 2x minus 19. All of these numbers come from these segments up here, and then that's going to be equal to the whole segment, which is 23. All right? Then from there, you have to combine like terms. So x plus 2x is 3x. Negative 6 plus 9 is 3. Minus 19 is negative 16. And that's equal to 23. Then you have to get x by itself. So you have to add 16 to both sides. So you're left with 3x is equal to 39. And then divide both sides by 3. And you'll get x is equal to 13. Okay? So you can do the second one the same way. If you put them all through here, 13 plus 6 plus 2x minus 18, that will equal to, now instead of a 23, you have this expression. The whole length is equal to 4x minus 29. So then you can gather the like terms. So 13 plus 6 is 19, minus 18 is 1. So you got 2x plus 1 is equal to 4x minus 29. And then if you want to solve, you have to subtract 2x from both sides. So you get 2x is equal to, and then you'll add 29 to both sides. You get 30. So you're going to get x is equal to 15 on that side. I went through that one pretty quick because I think once you see the first example, you kind of get the gist of how to do it. I wanted to show you the answer. All right. So that's how you handle segment addition. For the second part here, you want to use the angle addition postulate. So notice both of these examples are going to be the same, so I'm only going to do one for you. Notice you've got ABC, so they're saying this whole angle is equal to 122. And then each of the segments, ABD, this part right here, is equal to 8x plus 20. And then DBC is equal to 22x minus 3. So again, this angle plus this angle adds up to be the whole thing. So we'll add these two together and set it equal to 122. So it's 8x plus 20. And then plus 22x minus 3 is equal to 122. And then you want to solve. And notice we have a place for x and then we have a place for the angles. So we want to solve for x first. So that means combining like terms. 8x and 22x is 30x. 20 minus 3 is 17. And that's equal to 122. If we subtract 17 from both sides, we'll get 30x is equal to, and if you subtract 17 from 22, what you'll get is 105. And then you have to divide 30 into 105. So x is going to be equal to, well, 30 will go, it's going to be 3.5, I believe. I got a calculator here. 105. So we'll do 105. 105 divided by 30. That's 3.5. Yes. So our x here is 3.5. And then we'll take our x value, we'll plug it in where we see x for ABD. So ABD is just going to be 8 times 3.5 plus 20. So if you work that out in your calculator, 8 times 3.5 plus 20 is 48. For the second part, DBC, we use that expression. So 22 times the x, which we found to be 3.5, and then minus 3. So do 22 times 3.5 minus 3 is 74. All right, and you can check your work. 74 plus 48 should equal 122. If it doesn't, then you've done something wrong. So that's how you handle angle addition. All right. So try number 2 and number 4 on your own and see if you can come up with these answers. And I'll bring them to class and I'll help you out.